All right, so we are getting into Unit 2, which Unit 2 is about fractions. Now, I know that you had some background in fractions from last year, but we're going to start with a little review of third grade material and then get into the fourth grade stuff in just a few days. So this isn't in your workbook. Okay, I saw a couple hands pop up, probably asking for page numbers. Where we at? This isn't in your workbook. It is in your packet if you just picked up the new packet, and it'd be page 2, which would really actually be the very first page of the packet, because it's the start. But it's listed as page 2 on the bottom. And what we're going to do here, we've already done these which one doesn't belong before as a little warm-up. So I want you to look at each of these 4 shapes here. There's A, B, C, and D. I want you to tell me which one doesn't belong. Okay, so think about it for 30 seconds or so. Raise your hand when you're ready, and I'll start calling on some names. Remember, you can earn your Pokemon Dojo points by participating in answering questions, getting involved in class. So I'll give you about 20 or 30 more seconds to look at this. Find one that doesn't belong. All right, let's go ahead and hear from you girls. Sarah, let's start with you. Which one doesn't belong in your eyes? Oh, just a second. I'm going to close out of Class Dojo real fast on here because it's going to notify me every time I give you a point, which I'm planning on giving a lot of points today. So you're going to be hearing dings all the time if I don't close it out. So Sarah, back to you. Which one doesn't belong?
Line D doesn't belong.
Think D?
Yeah, I think it's D.
Okay, why do you think D? What stands out about D?
Because there's only half of it. There's only
half of it?
Yeah, there's only about that much.
So there's just a little sliver here?
Yeah.
Okay, how does that differ? How is that different from the other ones then?
Because C and D have full ones, but then also A doesn't have any.
Okay. How can cuts? Are they the same? Or are they different?
Different.
So they are different. Different size cuts. Because I almost view that dotted line, dashed line as like scissors cutting it. I don't know if you do too, but so different size cuts. There's a little sliver there and then a bigger piece there. Awesome. Thank you, Sarah. Elizabeth, does a different one stand out to you as being different? It doesn't belong?
C. Yeah, C.
C? Okay, so why C?
Because it's a circle. It's not a square like the other.
Okay, so circle, not, and I don't have room. I'm going to just draw a square. That's an ugly square. I'm sorry. That's an even worse square. That's a little better. Yeah, nice job, Elizabeth. Elizabeth said C because it's a circle, not a square like the other 3 options. All right, so nice. Sarah and Elizabeth have both earned a point so far today. Well, on top of being on time. Tania, does a different one stand out? Does A or B stand out to you?
A stands out to me.
Okay. Tell me more.
Because it doesn't have a split line.
Doesn't have a cut or a line?
Yeah.
So it doesn't have a cut or a line. So Tania says it stands out to her as being different. All right, awesome. And did someone see B as being the one that doesn't belong? Camila, I see you nodding your head. Do you want to give us your answer there?
I think B because it's the only one that's shaded.
Okay, only one that is shaded. Yeah, you can see over here, the right side, which I even double shaded. The right side is shaded, whereas the other squares or circles, the other shapes, whether they're cut or not, they're not shaded in any way. Very good, all four of you. Sarah, Elizabeth, Camila, Tia, thank you for your help on that. Whenever we do these, which one doesn't belong, we're really trying to see if each of them stands out for their own individual reason, right? We might see them in a different order, like maybe Camila saw that B stood out right away. Just a second, got some background noise. Camila could have seen B standing out right away because of the shaded area, whereas was it Sarah on the bottom saw the little sliver, maybe that stood out to her, right? We see things in a different way. We approach math in a different way. We approach a lot of things in life in different ways. And so it's cool to hear your guys' thoughts on what stood out to you. Okay, so let's go to the next page. So again, this isn't in your workbook. I'm sorry. This is the adaptation pack for this curriculum, and we don't have that in physical book form. So I have to just show you on Teams, but I can print it in packets. So if you have packets, follow along, please. If you don't have a packet, it's up on the screen that you're watching right now. And I'm going to award Eileen a point just for being on task. I see that she is taking notes and following along. So good job. Okay, looking at B, partition problems. Solve each problem. Draw a diagram. I'm going to highlight that. That seems important. Draw a diagram to show your thinking. A space on a table is shared equally for 3 activities. How much of the table is used for each activity? Okay, and it wants us to draw a diagram to show our thinking. Well, for this first problem, let's walk through it together, maybe with me leading the way. If I had a table, let's say a rectangular table. Oops, that's ugly. There you go. That's a little better. So let's say that this is the lunch table, and we have 3 activities that we want to put on it. Maybe it's for like a math night or a reading night or Halloween party or something like that. We want to put something on each of that's shared equally 3 different ways. Well, if I'm going to split it 3 different ways, how could I split this table up? What would it look like on my diagram? Can someone walk me through how I could cut this up into 3 different pieces equally? Camila, I'll go to you. How could I cut this up?
You could cut it in 2.
Cut it in 2 like this?
Cut it in 3.
Cut it in 3, okay. How would I cut it into 3 pieces? Where would my lines need to be?
One on the side and the other one on the other side.
So are you saying like right there?
Yeah.
There and there? Is that kind of what you're saying? Because you can let me know if you're thinking something different and I'll draw a different picture.
Yeah, that's what I was saying.
That's what you're thinking? Awesome. I'm going to color these so that I can kind of keep them separate. Okay, let me get green. And okay. So let's see. How much of the table, so answering this last section here, how much of the table is used for each of these activities? Well, since we're working with fractions here, I like to describe my fractions as parts over whole. Okay, parts over whole, and I'll write that for you. Remember, when we see fractions, this is a number sign. We see a number over a number. Okay, and fractions can be a little confusing, kind of wrapping your head around it, but I like to think of this as the part. So how many parts am I counting in reference to the entire shape? Okay, so I have a part on top, and I have a hole on the bottom. So how many pieces are there that make up that whole table, that whole piece. Okay, so if I'm trying to figure out how much of the table is used for each activity, well, each activity is only one portion, one part of that table. Right, so if there's only one part that is being used for each of those tables, each of those pieces, then if I'm trying to write a fraction that shows how much of the table is used for each activity, I would write the one part, so the one piece that's being used, over the whole. Well, how many parts are there in the whole? There are 3 pieces that make up the entire table, right? So there's 3 that make up the whole. Well, I have 1 part over 3 wholes. Do you know how to say this fraction in word form? Camila, since you started this problem, go ahead and finish it. What do we say?
3 multiplied by 1.
Not 3 multiplied by 1. We would say that each portion is blank of the table. Maybe I need to give a little bit more of a hint.
Table?
Part of the table? Is that what you said? Okay, it is part of the table, but we say that it is 1/3. 1/3. Have you heard that before?
I don't know.
What? You don't know? Well, that's why we're going over it. So if you have heard it, awesome. If you haven't, then you're learning new verbiage right now, new words. So we say 1/3 because there's 1 on top and there's 3 on the bottom. 1/3. So each part of the table that is for the activities is 1/3 of the whole table. Right? Okay, and I'm going to give Camila, Elizabeth, Sarah, Eileen, and Tania all points right now for being on task. So nice job. Sarah, Tania, Eileen, Camila, and Elizabeth. Nice job. On task. Okay, so let's look at this next problem here. So actually just kind of reviewing what we did in this activity, this first problem. We made our diagram, right? So we drew a diagram, we drew the table, we shared it equally for the 3 activities. We talked about parts on top, whole on the bottom. We were looking for one of those pieces, so 1 part. We cut up the table into 3 pieces, so 3 on the bottom. 1/3 is 1/3. Okay, let's go on to 2. Problem 2. 2 students, let me get my highlighter out. Come on now, there we go. 2 students want to share 1 piece of tape. So each student gets the same amount. How much of the piece will each student get? So 2 students sharing 1 piece of tape, and they want the same amount on each. Elizabeth, do you want to help me with that one? I saw your hand pop up. How can I draw this? It's a diagram.
Into a rectangle?
Okay, so I'll draw a rectangle here. Usually a piece of tape is kind of skinny, so I'll make it skinnier.
Then they could do half.
Do half of it. Okay, where would the halfway be?
In the middle?
Yeah, right in the middle. Like, is that what you're thinking? Straight down?
Yeah. Yeah.
Okay, let me get my colors out again to help us. Okay, if we're trying to, now going back to kind of this first problem, how we talked about parts and wholes, Elizabeth. If I'm trying to figure out how much of the piece of tape that one student will get, so each student individually, how many parts are there on the top of the fraction? Like if I'm trying to see how much the green person will get.
1/2.
Yeah. Yeah, exactly right. And you actually jumped ahead a little bit, which is good because this is review, so you may already have an idea about fractions. I'm glad that you do. So there's parts. If we're talking about just the green part, there's only one piece there, right? One piece for that side. How many holes or how many pieces are there that make the whole, Elizabeth? How many blue and green total?
2.
2. So we have 1/2, and we say that is a
1/2.
nice. Great job. That is 1/2. So each person, each student gets 1/2 of the tape because there's 2 people sharing one piece. Very good. Let's do this last one, problem 3. It's the last one we're going to cover in class, and then I'll introduce the homework and we'll be done. So some classes are sharing a basketball court for PE. Let me get my highlighter. If 4 classes share the court equally, okay, equally is important, how much of the court does each class get to use? So there's 4 classes, they're sharing the court. Basketball courts are rectangle, so I'm going to draw a rectangle first. Okay, kind of that shape. Actually, I'm going to try something different. I think I can draw. Ooh, nice. Look at that. Insert rectangles. That's a pretty rectangle. So if I were to share this basketball court with 4 different classes, how could I cut this up? And I saw Eileen's hand go up and then she left the screen. So Eileen, if you're there, I'm going to go to you. Eileen, how could I cut this shape up?
Put 3 lines.
3 lines where? Like there, there, there?
One down. One cutting down the middle.
Okay, cutting down the middle, so like that. About. It's not perfect. Okay, and then where else? Because I see 2 pieces. I need 4.
And then another one cutting down the right.
In the middle again? Like right there?
Yeah.
Okay.
And then another one cutting down the left.
In the middle again like that?
Mm-hmm.
All right, very nice. Yep, that would give us 4 equal sized pieces. Let me get my colors out again so I can see each of the classes on my basketball court there. So now if we were to take this part and whole again, Eileen, how many parts are there if we're trying to find one class's size?
There are
I'm trying to find how much of the court each class uses. So if I'm trying to find what fraction that each class uses, how many parts does one class have?
1.
Yeah, they only have one piece of the court, right? They only have one section that was cut up. Okay, how many total pieces are there in the whole?
4.
Yep, there are 4. Do you know what we say for this fraction? How we say that?
1/4.
Yeah, 1/4. Nice job. I'm very impressed with what you guys remember from last year. Are there any questions on what we covered in this recap of unit fractions? Okay, unit fractions have 1s on top. And 1 piece of the whole. Can I see thumbs up, sideways, down? Okay, I see thumbs up. Thumbs up. Awesome. Double thumbs up from Elizabeth. Wow. She's getting crazy. Okay. Here's the homework that we're going to do. It's just this one page. It's in your packet. It's also in Teams. Okay. Let me zoom out a little bit so you can see majority of it. So it's no different than what we've been doing in class today. Okay. This first part here, divide the whole into equal parts and label each part with its unit fraction. So you're going to split the rectangle into 2 equal parts, into 4 equal parts, and then move on. And I want you to write how many equal parts there are in each of the shapes. Shade one of the portions, like this one down here for 5, 6, and 7. Shade each one part of the fraction, of the diagram, and then write its fraction in the blue box. Okay, and then for this last part down here, 5, 6, and 7, circle the correct unit fraction that shows how much is in that shaded region. Okay, so that's all your homework. I'm going to stop sharing my screen, stop recording.